All right, so as we start 3.6 in Math 9 here, I have a question up on the board. You guys had a minute to look at this. There's two different answers that these students got. So here's the question, and it says -8 minus 2 times bracket 24 divided by -8 all squared. And so these two students got two different answers. Can anyone tell me why they got, first of all, does anyone want to tell me why they got two different answers, where they did something different, or just tell me where one of them maybe went wrong? What are your thoughts? Yeah.
On the first one, they just did left to right.
Okay, first one you said they just did left to right. So they just did all of the operations as they appeared from left to right? That's what you're saying?
Yeah.
Okay, so let's see. The first operation that would seem to appear here would be -8 minus 2.
Yeah.
And that looks like what they did to get -10. Okay? And then, well, then they went inside the brackets here, I guess. They didn't do -10 times 24. They went inside the brackets, so that was a good idea. And then they evaluated the square before the multiplication, so that's a great idea. So it looks like the problem arose when they just isolated this part right here of -8 minus 2. Okay, so that's a bit of a problem. Okay, I like that. What about over here, the next one? What did they do differently? What did they do wrong? Was there a step that was incorrect? Yeah.
I think on the third part. Like
On the third line?
Yeah. They did like on the fourth line side.
Yeah.
They did like they did negative plus a negative is a negative instead of like a positive. So they got -36 instead of positive.
Oh, I see. So, okay, so you're saying that right here, this -6 squared, you're saying this should be a positive
Yeah.
and not a minus. Okay, -6 squared should be a, okay, so let's just talk about this for a second. -6 squared is a positive 36. Now, in this step though, if you're looking at these two steps, right, this negative right here is dropped down here. That's good. This negative, right, turns positive when squared. So actually this right here is correct. That is okay. That is okay. I think it was just a little bit before that where I see a problem. Go ahead.
Did they do 2 times 3 before doing the 3 squared?
Yes, I think you're right. That's what I spotted too. So this 2 times -3 to get -6, that's what they did before the squared. Okay, now we know from what we've learned before about order of operations, right? If we have multiple operations, there is a specific order that we have to do this, right? In order to get the proper answer. And exponents, evaluating exponents would come before multiplication, okay? All right, so you've spotted 2 errors correctly there, okay? Now, the order of operations, as you know, and as we even mentioned last class, I think, that the order of operations are summarized in a neat little memory mnemonic called BEDMAS. Everybody remembers BEDMAS, okay? You might hear it if you look up some video on the interweb. You might see PEDMAS as well. So P or B, both mean the same thing. They mean brackets. P is for parentheses. So you might see that, but I always teach it like this: BEDMAS. And I like this little, and this is in your notes as well, this little chart here. The B stands for brackets. Okay, so if there's any operations inside brackets, we do those first. Next step would be to evaluate exponents. So E is exponents. Any exponents, we do them next. And if we look back, let's see if there was anything that was done correctly. So yeah, this right here, you see the brackets. This is an operation that's inside brackets. And so they did this one first, which was absolutely correct. Over here, they did the subtraction first and ignored, what was inside these brackets. And so that's not good. Plus, as we'll find out in a second, the division and multiplication, whichever one comes first, left to right, that has to be done next. So divide and multiply in order from left to right next. And finally, addition, subtraction is last. So add or subtract in order from left to right, that comes last. And going back to our first example there, they did the subtraction very first. So that was totally backwards. That doesn't work out. Okay? All right. Very good. I want to just show you this example. This is not in your notes, but I want to show you this example and just work through it. This is from your textbook. So Pearson Math Makes Sense 9 here. And I don't know what page this is on exactly. 138, I think. So if we have a series of operations like this in A, let's focus on A first. You see that we have addition, we have division, and we have multiplication. So if we look at our order of operations, there's nothing inside brackets that is to be done, like no operation. There's just single numbers inside brackets, so we can like move on to the next step. Next is exponents. I don't see any exponents on any of the numbers, so we'll move on to the next step. And then comes division, multiplication. So those two can be done in order from left to right. So definitely we're going to do this one first and then this one second. Okay, so there we go. Division, then multiplication. Now notice that we take the number that's before the divided sign and the number right afterwards, and we evaluate this value first. So 1.2 divided by negative 0.3 right here is negative 4. Okay? And you can feel free to do this stuff on your calculator as well, no problem. And then we move to the second one, which means that this result, okay, because we did this first, this result then gets multiplied by 1.5. So this is the next step that we do. There's 2, you see. Here's 1, here's 2. And so then we get this negative 6. And finally, this is the third step here, the addition. And we add this number plus whatever we got from doing the first 2 steps. So here's our first number, and this is what we got from the first 2 steps here. You see that? So you do those in order, do one at a time, record that answer, and then include that in the rest of your steps there. So we end up having negative 0.8 plus negative 6, and we get negative 6.8 as an answer. Okay, any questions about that? Okay. All right, so please show your work. Show your work like this. And again, in high school, I know this is, with you guys, a lot of your math has been, in your head. You're not writing everything down. It's on your calculator. You do a couple operations in a row and write down the answer, and then you do some more, and you write down another number over here, and you got it all tracked in your head, and you got an answer, and you circle it, and you move on. A lot of the stuff you've been doing is pretty straightforward, and you guys are kind of coming now beyond that, where something like this, there's multi-steps, and you are going to be required to show your work so that you can keep track of all the little details. And trust me, this is grade 9 right now. In grade 10, grade 11, grade 12, okay, and I'm teaching calculus in grade 12 right now, and they are doing 1 question per page. So they fill up their whole page with work. That's 1 question. Takes them 10, 15 minutes sometimes. That's what we're doing right now in calculus. So you cannot just punch in numbers in your calculator and do all this stuff in your head. And how'd you do that? Well, I just punched numbers in my calculator. Cannot happen. You have to show your work. So this is where we start. This is easy. And I can tell you, and some of you are looking at me like really awestruck here, but when you get to grade 12, when you get to calculus and you do a question like that, trust me, these guys, it's challenging for them, but it's not impossible at all. And we do it step by step, and you just are adding your skills together. So we're learning these kind of skills here. So what I'm encouraging you to do is to take this that you see in the textbook and that you see that I do, and mimic that. Practice showing that work, showing step by step. I know this seems like a lot of writing, okay? And you're like, all right, I can just do this on my calculator. 6.8, I'm fine. I want you to start working through this, showing your steps, showing your work, displaying each sort of step along the process, okay? Because you will need that as you move through into more difficult areas of math, okay? So I won't spend any time on this next example. You can look at this in more detail if you want a little bit later, just another example. But what I'd like to do is to get, I'll save this word problem maybe for later. Let's get to your notes and bring that all together here. So this is the notes package that you should have in front of you now. Let's do question A and make sure that we can do, a series of operations that have just 2 operations here. All right, so A, we have a division and multiplication. Now I look on my list and there's no brackets, there's no exponents. Oh, here's division and multiplication. Now, what does this mean again when you have this little bracket here? The D and the M seem to be connected together. So what does that mean? Can someone verbalize that for me again? What does that actually mean?
It's division mark.
Yeah, the D and the M stand for division and multiplication, but what does this connection between them mean? What does this connection mean? Yeah.
It means whichever one comes first.
Okay, so it means that they're on the same level. Okay? So in order, they're tied for third. In the order, they're tied for third. See? And addition, subtraction's tied for fourth. So tied for third means that whichever one you come across first as you move from left to right, that's the one you do first. Because there's no discrimination between division and multiplication. They're tied for third spot here in the order. So that means that I would just go ahead and do, and let me zoom in here now so you can see that in the back. So I would just go ahead and do this division first. All right? So this expression is going to equal, and I'm going to use my calculator, and you can use your calculator, that's no problem. So we're going to go, well, we're going to turn our calculator on. And I'm going to go negative. Make sure you use your negative button, not the minus button, but the negative button for the first number. 2.4 divided by 1.2. And I'm going to get negative 2. Awesome. So I write negative 2 as a result of this first step. Then I'm going to write times, and I don't like using the x, right? I told you about that because x is our preferred variable when we're doing algebra and, you know, and like that calculus class I told you about, we use x all the time. So we don't do x for times, we do x for the unknown variable. So you'll see that still in these notes, and you know what that means, but I would encourage you to use that big solid dot as multiplication. Or you can just write it like this. This, just brackets around them right next to each other, that means multiplication as well. So try and get away from that x. I know they're in the notes, but we'll try and work ourselves out of that, okay? All right, so now we just do this multiplication. Okay, one more step to do. That's pretty easy. The answer is going to be negative because it's negative times a positive. And if you double 0.2, you get 0.4. Don't need your calculator probably for that one. Okay, and that should be your answer. Does everyone agree with that? Does it look good? Is that the right answer that you guys got to? Yeah? Okay. Awesome. What about B now? Let's take a look at B. So this is great. I have lots of stuff going on here. I have brackets. This looks like it's going to be number 1 on the list, right? I should do this operation. Even though this is addition, please don't look at this and say, oh, I can't do addition. It's last on the list. No, it's inside the brackets. So that takes precedence. That means that the brackets, whatever's inside the brackets, you have to do that first, okay? Even though subtraction is down the list. It's brackets that come first. Next would be what? Would I do the addition? Would I do this exponent? Or would I do multiplication? Which one should come next after brackets? Exponents, right? It's bed mass. Okay. So that means that this right here is going to be number 2. Now, you don't have to write number 1 and number 2 above the, I'm just doing this to teach, right? So I'm just making sure that we're all on the same page here. So you can do this if you want. It's not a bad idea. But you don't have to because it's going to get complicated. What I mean by that is this now answer, you have to do the multiplication next, right? Before the addition. So this is going to be the third step. And then finally, this addition. So we are going to do whatever this was plus whatever this is as the fourth step. So that's what I mean. It can get a little bit confusing if you do this. But let's give this a try now. So number 1 was negative 3.4 plus 0.6. That's going to be what? Negative 2.8? Everybody okay with that? Awesome. Okay, I'm going to leave that alone now. And I'm going to do 2 steps at once. That's totally fine because watch this. I'm going to leave the plus there. But I'm going to now also evaluate this 4 squared, which we know is 16. Very good. 4 times 4. And then times 0.2. All right. So good idea to do, you can do 2 steps at once in one line of work. I'm totally fine with that. Again, I know I just mentioned this, that you should show every step in all your work. You can do more than 1 step in one line of work. Just don't do all of them in your head and not write anything down. That's all I mean, okay? So this is fine. I did 2 steps at once. That's totally acceptable. Now let's go ahead and I'm going to do just this 1 step at a time now. So I'm going to leave negative 2.8 over here. And what's 16 times 0.2? Now, before you get your calculator out, think about it this way. This is what we've been working with the last couple chapters here. 16 times 2 is what? That we could figure out in our head. That's 32, right? So I don't have just 2, I have 0.2. So let's move that decimal place over 1. So 32 becomes 3.2. Yeah, does everyone see that? There's lots of different ways you could do this in your head without a calculator. I challenge you to try and work through that. And certainly check with a calculator, okay? This is how you train your brain. You do it mentally. You're like, yeah, I have a process. I can do this in my head, or I know how to do this. Now I'm just going to make sure, because I'm maybe not 100% confident, so I'm just going to double check here. Oh, boom, got it. This is how you train your brain, okay? The more you can do mentally, the more efficient your processes are going to be, the quicker your processes are going to go. And I would encourage you not to rely blindlessly on your calculator all the time if you can help it. Okay. I'm doing a lot of preaching today, aren't I? Okay. What about this one? Can we do this in our head? Should be. 3.2 is the larger one. It's the positive one. And minus 2.8. So what's just the difference between 2.8 and 3.2? Or 28 and 32 is 4. So 3.2 minus 2.8 is 0.4. Yeah. And let's check that on our calculator just to be sure. So negative 2.8 plus 3.2. 0.4. Awesome. Okay, so I think that is the correct answer. Does anyone agree or disagree? Agree or disagree? What do you think? Did we do all that right? Yeah? Okay. Okay, on a scale of 0 to 5, how easy is this for you? 5 is really easy. I got this nailed. 0, I have not been listening the last half hour. Where are we at? Somewhere between 0 and 5. Hopefully no zeros, but okay. I'm seeing a lot of fingers. This is good. The students are all giving me fingers. Okay. Generally, that's not a good thing, but is that a half there? Your thumb is like, that's a half? Okay. All right. Anybody else have halves? Can anybody else do this? Half of a finger? I don't know. That's not everybody can do that, but okay. Okay. All right. Good. If you're a 1, don't use the middle finger. Okay. I'll take offense. Okay. Please don't do that. All right. Just kidding. Okay. Well, I'm not kidding, but I know you wouldn't do that. All right. So can we move on to C then? Yes? Okay to move on to C? Okay. Fractions. Ooh. Fractions freak me out. Fractions freak anybody else out? Trick question. Don't say yes. They're just regular numbers. They want to be treated like everybody else. Don't discriminate against fractions now. Okay. All right. Okay, so all of the same order of operations hold true. What's the first one again? Can't remember. Brackets. Thank you. Brackets. Okay, brackets. So do we have any operations inside brackets here? I do. This one is an operation. That's a subtraction inside brackets. So that one I'm going to do first. Let's go ahead and do that. Oh, I have a how do I subtract fractions again? Do I just go 3 minus 7 and 4 minus 8? No. Common denominator. Right. Almost forgot. You guys are so smart. All right, so I need to get a common denominator of 8, right? You can multiply 8 times 4 and 4 times 8 to get 32, but that's a big number. You don't need to do that. You're going to have to do some simplifying later. So just go to the lowest common multiple between 4 and 8, and that would be 8. Right? Is everyone okay with that? You're good with that? So let's just go to 8 here. So that's going to be, now, here we go. I don't want to make any mistakes, so I'm going to rewrite this. It's going to take me, 10 seconds maybe. All right, so I now have this fraction here, and maybe you could do this in your head. That's okay if you do. But I have 6 over 8, now minus 7 over 8. So 6 minus 7 is negative 1 over 8. Very good. Divided by negative 5 over 16. Okay. So is this, does this negative right here on the 5 over 6, does that mean subtraction? Am I subtracting here? Is there a subtraction operation to do here? No. That's a negative number, right? So sometimes this minus sign means subtraction, But sometimes this minus sign is just a negative. So this case, it would be a times negative b. That minus does not always mean, that negative sign does not always mean minus. So good. And again, I don't know what you're thinking. I've had students before think this way, that, oh, that's a minus. I got to minus something. I got to subtract. No. This is the operation that has to happen. Division. And those are just negative numbers we're going to divide. So let's keep going with this here. Someone remind me, what's the rule with the dividing fractions? What do you do? Common denominator? For dividing, you don't have to actually. No, that's just for adding and subtracting. But, good guess. What's the rule with dividing?
You flip the second fraction.
You flip the second one, fraction, and
Change the sign to a multiple.
multiply. Right, you flip and multiply. Flip and multiply. Flip and multiply. Okay? Flip and multiply. What is it? Flip and multiply. Okay, you flip and good. Flip and what? Multiply. Okay, good. Just want to make sure I remember that. Okay, so I've got negative 1 over 8. You guys think I'm crazy. Times. I'm going to go times now. And what does flip mean again? How do I flip?
The second one.
I flip the second one, and flip means you take the reciprocal, is the fancy word for it. You flip and you, so I'm going to, now the negative can go anywhere. I'll keep it with the number it was on, just so I don't confuse anybody. But you can leave it up on the top too. So you see that flipping means taking the reciprocal. So flip and multiply. Now it's just a multiplication. Awesome. What's something that I could and probably should do to save myself some energy later on? What should you look for before you actually multiply straight across? Yes? Simplify. So you look at a number that's on the top and a number that's on the bottom. If those can be simplified, then you should do that. So I see 16 and 8. That actually turns into a 2 over 1. 16 over 8 is 2 over 1. Now, can 1 and 5 be simplified any further? No. 2 and 5? No. 1 and 1? No. So now I go ahead and multiply straight across. I've got a negative 1 times a positive 2. So that's negative 2. And what did I have down here? That was a negative 5, right? That disappeared on me. Computer! So I got negative 2 over, oh, actually we could have simplified the negative and negative, right? That turns into a positive, but we'll do that this time. So negative 1 times 5, there we go. So we actually have 2 over 5 is our answer. Good? All right. Okay, D and E are yours. D and E are yours. Go ahead, please do D and E. Do that on your own, and I'll show you some answers there after a couple minutes, and we'll see how you did. All right, so let's take a look at D. Now, order of operations say I have to do the multiplication before the addition, so I have to do this first. And I noticed that a 2 and a 6 can simplify to 1 over 3. So I get negative 1 over, 3 times 3 is 9. Then I do 1 over 9, negative 1 over 9 plus 1/2. I need to get a common denominator of 18. And so then I have negative 2 plus 9 is 7 over 18. So there's my answer for D. Any questions about that? Or did anybody get a different answer and think this one's not correct? Yep. You got 4 over 3? Okay. What did you do differently than me here? Did you see? A different denominator? Okay, 4 over 3 you said. No, I'll have to come check your work a little bit later. That's not correct. Yeah. Yep.
In this case, at least you didn't have to simplify because you needed it.
Right. Yeah. So, okay, in this case, you didn't have to simplify because you needed it. Okay. You would have ended up with negative 2 over 18 here if we didn't simplify. That's right. So we still would have had to have multiplied this one, but yeah, you're right. I divided by 2 here, and then I had to multiply back by 2. You don't necessarily know that, though. You don't know that when you start. So good idea to simplify, because if numbers are bigger and you have to reduce, sometimes that's a little tougher, right? Like, you know, if you have like 54 over 26, it's like, that's a little bit harder to reduce than, you know. So you're right, though. As it turned out, we didn't need to divide this out, but that's always a good practice. All right, E, let's take a look at the second one here. So E says I have these mixed fractions, and I have an addition, and I have a multiplication. So of course we're going to do the multiplication first. First step is to change these mixed fractions to improper fractions. Then I simplified this multiplication here. I saw a 2 and a 4, so I simplified those. Now I did this multiplication, and I get -5 over 6. So once this is done, then I'm going to have a common denominator for this addition, okay, which comes to us 6, and I have a common denominator of 6. 14 minus 5 is 9 over 6, and that can be simplified by dividing each by 3, and then you get 3 over 2, or 1.5. Does anyone see anything in there that you're not understanding or disagreeing with? We can work through. Anything little that you spot? Okay. All right. How are we feeling about order of operations today? Feeling okay? All right. I'm going to do one more example with you, this word problem that I said I'd save till later. So this is the last example. You do not have this in your notes, so I want you just to watch, okay? This is how you would work this. So you can write this down on the back page if you want, or on your note paper if you wish, or you can just watch. So this word problem says to convert temperature in degrees Fahrenheit to degrees Celsius, we use a certain formula. So Celsius equals whatever the temperature is in Fahrenheit minus 32 over 1.8. Now we have to remember something that's pretty important, that this little ratio sign, what operation does that seem to indicate? It's division, right? It's division. So interesting. This is going to be a little tricky because, and I'll show you why. In Fort Simpson, Northwest Territories, the mean temperature in December is -9.4 degrees Fahrenheit. What is the temperature in degrees Celsius? So watch very carefully, because this can be confusing. When you have a ratio like this, okay, what you don't do is you don't write it like this. And you say, Mr. Maxwell, why can you not write it like that? That's exactly what it says. Well, it doesn't actually mean this, and I'll show you why. Because this right here, when it's written like this, the whole expression on the top, the f minus 32, that's all divided by 1.8. If you were to write it out just like this looks like it's just the 32 that gets divided by 1.8 and not the f. Okay? So you have to be careful, because you're gonna get two different answers if you write it like this. This is gonna be the wrong answer down here. So what you have to do is you have to understand that this is this whole thing divided by 1.8, which would be brackets around here, which totally changes the game. So if you have an expression in the numerator of a rational, you can, if you write it out in a row, put brackets around that. And then the same thing goes for underneath here. If there was more than one operation under here, put brackets around those as well. Okay? Was there a question before? Did you get your question answered? You good? Yeah, that's right. You can put brackets there. So -9.4, that's pretty easy now. I do -9.4 minus 32, and I divide that by 1.8. So this is how you convert Fahrenheit to Celsius. And so let's see what the calculator says on this. -9.4 minus 3.2, 32, not 0.2, minus 32. And on your calculator, you can use brackets, or you can just kind of say, hey, I'm going to do this operation on its own first, -41.4. And then I'm going to do a second operation. And then you take that number and you divide it by 1.8. Is minus 23. And -23. -41.4. Okay? So that should be your answer there. -9.4 degrees Fahrenheit is actually -23 in degrees Celsius. And a word problem, make sure that you have clearly communicated what your answer is with proper units. You don't need a word sentence, although word sentence would be very clear, and it would be appreciated. All right, any other questions before I give you your assignment? Sorry? What was it? What's that? Why would Northwest Territories be using Fahrenheit? Well, they might not use Fahrenheit, they might want to use Celsius. That's why we're calculating Celsius. Northwest Territories is in Canada. Fahrenheit is generally used in the United States. So one could say that it is negative 9.4 degrees Fahrenheit anywhere in the world, because it's just a representation of a temperature. But you're right, probably people would be more familiar with degrees Celsius than degrees Fahrenheit in Northwest Territories. But let's say there's an American that's visiting Northwest Territories, and they have no idea what 23 degrees is. What's negative 20? What's minus 23? I don't get that. Well, then someone could tell them what degrees Fahrenheit was. Or if an American was visiting and told a Canadian what the temperature was while they were there in their own units, then we could do this calculation and figure out what the temperature would be in degrees Celsius. Okay. And of course, I know you would just punch in, into an app or something on your phone and it would tell you. I get it. But all those apps and those calculators, and they all use the math that you're learning. So this math is foundational to a lot of things that we use in everyday life. So whether you actually get out your pen and paper and do this kind of calculation or not, we do have to learn it because it's the basis of everything that we use, and it's an important foundational concept. So yeah, I know. That's just a math teacher talking. I know. Okay, let's get to your assignment. So